Hi, here we are with harmonic motion notes day 1, problem number 3. And I've already drawn my lines for my sketch and I've already read through the problem one time. So I'm really ready to start putting things on my graph here. But even though it says we're going to call our starting time 0, I don't know anything about how many foxes I have at 0. So I need to look at where I know something about the number of foxes and the time. And the first place that happens is right here. It says there's a maximum number of 800 at time of 0.9. So to me it makes sense to say, okay, well that's my maximum. And I know it's right there at time 0.9. Then the next part says, now I have a minimum, well that's obviously this part right here, of 200 foxes, and that occurs at 1.5. Well, I know with my cosine curve, it goes here, 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 like that. So the minimum gets hit at 1.5 right here. So now I've used up my information up here to get this far, and now I need to just fill in the missing pieces. I know I can average these, add these up, divide by 2 to get my middle number of 500. And I can do the same thing here, add these two up, divide by 2 to find my number in between. To find these other two numbers over here, I would need to know how far it is from one of these to the next. Well, no matter if I'm looking at this one or this one, I can just subtract them, and what I find is 0.3. So that means this one from here to here, I add 0.3. Well, that's 1.8. And if I add another 0.3, this one becomes 2.1. And I'm also going to go ahead and draw in my curve here. Okay, it looks like everything is drawn on my curve, so now I can go ahead and fill in my A through E and my increment. A is this distance here, so by subtracting, I see that's 300. B, I'm going to come back to in a second. C is where I start on this way. That's at 0.9. D is where the middle line is right here. So that's 500. And the increment was this thing right here. How far is it from one to the next one? Well, that's 0.3. Now to find E, I have two options really. One, I can do my last one minus my first one because this distance here is E. So I can subtract 2.1 minus 0.9. Or I also know that it's 0.3 4 times, so I can multiply 0.3 times 4. Either way, I get 1.2 for E. And as we've discussed in class, we know that B is really 2 pi over E. So that means that B is just 2 pi over 1.2. I could reduce this, but since I'm going to put it in the calculator anyway, I'm not even going to reduce it. So I'm going to write it out here on my line, 300. I know because we start at the top and go down, this is the shape of a cosine curve. 2 pi over 1.2 x minus c plus d. And part B is done. Part C says, let's find this fox population when the time is 7, 8, 9, and 10 years. So I'm going to plug this in for T or for X, whichever one you like to use. And I'm going to put this equation into my equation solver. So I have my calculator. I already have it with a cosine here from last time. So I'm going to go ahead and put in my A, B, C, D. Now I didn't put anything in for x yet because I just wanted to get my equation itself all set up right. And now I'm going to say, okay, so I want my x the first time to be 7. So I'm going to go back and put that in. And my y for 7 is, I pushed the wrong button, 759.80. But what were we looking for? We were looking for how many foxes there were. I don't like the idea of having 0.8 foxes. It makes sense to round off to a whole number of foxes. So this is going to round off to 760 foxes. Okay, now we're going to do 8. Oh, same answer. Do 9. $499.99. That sounds like 500 foxes to me. And lastly, 10. $240.19. So that sounds like it rounds to 240 foxes. So that's part C complete. Part D. It says foxes are declared an endangered species when their population drops below 300. So I want to look on my graph at where that happens. Now, the population, that means this number we're looking at is y, and we want to find the t values or the x values there. So I'm going to just make myself a little note. I want to know where y is 300. I want to know what the x values are. If I look up here, I can make an estimate where 300 would fall here. That's going to fall kind of close to the 200. About there would be my 300. So I can get an estimate of where this is going to happen. And my problem says when their population drops below 300. So I'm really talking about this part of my graph down here at the bottom. So I want to know, where does this one happen? And where does this one happen? So I'm going to put on my calculator 300 for the y. But if I leave my graph like this, it's going to look for where is y 300 close to 10. Well, I know it happens in more places, so it's not going to find this one if I leave a 10 there. So I need to make a guess that's close to this one right here. Well, this is close to 1.2, so I'm going to put 1.2 and then do the solve here. And it says that this happens at 1.33, and this number is time in years, so it's okay to leave the decimal there. And if I look at my graph, 1.33 falls between 1.2 and 1.5, so that seems very reasonable to me. I also want to find this one, and I'm going to estimate 1.5. I'm going to estimate 1.8, this one right here, for it. So on my calculator, I'm going to put in 1.8 and hit solve. And it says, well, it's really 1.66, and I'm going to put that on my graph and say, yeah, 1.66 looks possible between 1.5 and 1.8, so that seems like reasonable numbers. So I'm going to write them down here for my answer. It says when, between what two values were t were the foxes endangered? Well, it's between those two. So between 1.33 years and x equals 1.66 years. And as it works out, show on your graph that your answer works out. We already did that. Thanks for listening.